Mr. Weston here with another video. Here we're finding a derivative using the definition. At this point in the course, we don't know many rules about derivatives, so what we're going to do is just apply the definition pretty directly. Here we're given the function f of x is equal to x squared plus 2x minus 3, and we're asked to find f prime of x. Again, f prime of x is looking for the derivative of the function, basically the formula that we need to find the slope of the tangent line to any value of x for the function. I know this idea is still a little complicated, but we'll get through this. F prime of x is, by definition, the limit as h goes to 0 of f of x plus h minus f of x all over h. And from here on out, it's really just a matter of algebra. We still write the limit notation and do exactly what this says. Notice this says f of x plus h. Compared to f of x, the notations there is trying to tell you, instead of writing x's, we're writing x plus h. Use that notation to your benefit. So everywhere we see here an x, we're going to plug in x plus h. Now we're going to subtract all of f of x. Notice we subtract the entirety of that function. Many students will get this incorrect the first few times, and that's okay. You're just trying this stuff out the first time. But do remember, we're subtracting the entirety of that function, so we really do need those parentheses. Moving on, we take the limit as h goes to 0 of x squared plus 2xh plus h squared plus 2x plus 2h minus 3. And now I'm going to distribute the negative. I do this in a very specific way and don't really do a lot of cancellation here at first, because if we look through the pieces of this, we see many of these same pieces. Note, x squared minus x, those add to 0. 2x and negative 2x, those also add to 0. And negative 3 and 3, you get the idea. So now, once I've done that algebraic step, I have 2xh plus h squared plus 2h quantity over h. Do note now, it's very clear, we have h terms in all of these, so we can factor out that h. And now cancel those h's. At this point, and only at this point, is it now acceptable to plug in that value of h. Before, we couldn't do that. H going to 0, well, if we're dividing by h, we can't plug a 0 in there. That's an undefined value. We may also get an indeterminate form. So we can't do that at this point at all. We have to wait until the very end here and now say, hey, plug in that h is equal to 0 to get 2x plus 8. Excuse me, 2x plus 2. No, I only drop the limit notation once I've actually taken the limit. You do need to include this. I know it's more handwriting, but it really is important to include that all the way through. This is a simple example, quite frankly. We're going to get to much more complicated ones very soon.